So welcome to my presentation. My name is Michel Dubuisson. I'm a functional engineer at BOSAL Energy, mainly responsible for performance of heat exchangers. So today I'm going to take you on a little bit of a journey of the last 20 years in our heat exchanger business. So the title is SOFC and SOEC hot balance of plant systems, and we go on a journey from the prototype all the way until our robust production processes into serial production. If you have some time left today, please visit us in booth A31. I know there's not a lot of time left, but anyway. BOSAL at a glance. So what is BOSAL? BOSAL is founded in 1923, makes roughly 650 million euros of revenue, has 22 centers worldwide and over 2,500 employees. We are present worldwide with a center of mass in Europe, but also presence in North and South America, South Africa, and Asia. So what do we offer? We offer flow and thermal management solutions. Typical challenges we see with building these products are performance, like pressure drop and heat transfer, manufacturability, ensuring it fits in the packaging, and in the case of the right picture, also reforming and phase change. Right, so our core technology, and I'll go back one slide, our core technology are the red boxes, which contain our heat exchangers. The surrounding components, they are also part of our offering and include, for example, pipes, half shells, and catalysts. So our core technology, the heat exchangers themselves, are characterized by their high effectiveness, low pressure drop, modular design, and its high temperature operation with limited chromium evaporation. The product offering goes from the smallest footprint, which is the P3, which is about this big, to a P6, which is about this big. And we can serve a power level range of between 300 watts and 300 kilowatts. And if you combine multiple units together of the largest unit, you can even go into the megawatt domain. It is also possible to coat these heat exchangers with a catalytic coating to ensure that you have, for example, a reforming reaction or an oxidative reaction inside the heat exchanger. So let's start at the onset of the SOFC and SOEC hot balance of plant journey. An example of our very first prototype is in 2006, where Rolls-Royce Fuel Cell Systems contacted BOSAL to work together and asked us to develop a hot balance of plant system, so including a heat exchanger and some piping. BOSAL accepted this challenge and did studies on performance, material durability, and manufacturing. This data is available online, as it is a European subsidized project, and you can find it if you follow the link in this presentation, should you download it later. And a year later, this prototype has been built. It is a scale model. So the original intent of Rolls-Royce was to create a 1 megawatt solid oxide fuel cell system, which was pressurized with a microturbine. And we made a scale model, 15 kilowatt equivalent, which was one of our first prototypes, and we got positive feedback on that. So before this and after this, many other customers had the same idea to order prototypes in order to validate their proof of concept. So if we move further to the proof of concept, these other customers were located in Europe, US, and Asia, and enabled us to increase our development in simulation, but also in testing. So simulation, you can see on the top right an example of a CFD simulation where flow uniformity is investigated in order to increase the effectiveness of the heat exchanger, and the pressure drop is minimized, and the heat losses to the environment are mapped. On the bottom right, you can see an example where the durability of a component is simulated by means of thermal cycling. It is named the thermomechanical fatigue simulation. And then this way we can identify the weak spots in the design before it occurs. Well, we don't only do simulations, we combine it with test results to validate. So in-house, we have the capabilities to test, to measure the performance. So you have to think about pressure drop and heat transfer. But we also have capabilities in-house to measure the conversion of gases while there is reforming in the heat exchanger or oxidation. On the bottom right, you can see an example of two heat exchangers mounted in parallel, powered by a single heat source, which is a flow at high temperature, roughly 700 degrees Celsius. And the valves are controlled such that the heat exchangers can be thermally cycled and rather aggressively. So with this approach, we managed to induce a thermal transient of 300 degrees Celsius per minute. And we did this to improve the durability of our products. So generation 1 product is on the left, and generation 2 product is on the right on this picture. And with this combination of simulation and testing, we managed to improve the lifetime from 1,000 cycles to 3,000 cycles. So over the years, it became more apparent that we needed to invest into optimization because the market demand was there. In 2018, we anticipated to manufacture 25,000 laser welded heat exchanger cells. And at that time, it was anticipated in 2024 to be 4 million laser welded cells. So that requires optimization. Additional reasons to go forward into serial production are listed on this slide as well. So for example, our heat exchangers have been exposed to real field conditions at our customers, and the feedback was mostly positive. And when it was negative, we did post-mortem analysis to understand the root cause of the problem and to ensure that it would not occur in our future designs. So on the bottom left, you can see this laser welding machine, which fulfills a welding quality standard ISO 3834-3. And then we move ahead to the robust production processes. So you can have high throughput, but it needs to be, there doesn't need to be a lot of downtime in order to make it successful. So you have to check tolerancing of components in order to ensure that your welding process can be consistent. We did welding accessibility simulations to check if the welding torch would be able to access all welds before anything goes wrong, of course. We did manufacturing process optimization, value stream mapping, and we implemented a quality management system called IATF 16949. All right, so we end up at the conclusion. Since 2006, BOSAL started a journey in the field of SOFC and SOEC with its hot balance of plant flow and thermal management solutions. BOSAL's product is recognized as a leader in terms of performance, durability, CapEx, and OpEx. And since a couple of years, industrialization is deploying in full. All right, so at the bottom left, you can see the key characteristics of our heat exchangers, which are the high effectiveness, over 90%. It's low pressure drop, 5 to 15 millibar. We can handle temperatures of up to 1,000 degrees Celsius. It's compact packaging, it's modular architecture, so we can go from 300 watts to over a megawatt. It's integrated functionalities like the reforming and oxidation and mixers as well. And we offer innovative energy as a service, which means that our engineers who have specialisms are able to help you solve your problems as well. And it's also durable, so we intend to improve that over time as well. But I see I have some time left, but I don't need it, so thank you for your attention. And if you have time to visit us at booth 831. Thank you.